Hello, bonjour, it's Laura here. In this video, I'm going to use some stoichiometry to solve a problem. The question at the top of my screen is, how many grams of carbon are required to react with 2.5 moles of Fe2O3? So that would be iron 3 oxide. Okay, so then we've got a balanced equation here as well. So iron 3 oxide plus 3 carbon will produce 2 irons and 3 carbon dioxide gas. So as always, we need to first figure out what our given and our needed are, and then we can figure out what our plan is. So our given is the 2.5 moles of the iron 3 oxide. So 2.5 moles of iron 3 oxide. So the formula is Fe2O3. And then what is needed is grams of carbon. Okay, so notice that we're going from moles to grams, and they're moles of a different substance. Like we're starting with iron 3 oxide and then we're going to carbon. So what our plan is going to be is we'll go moles to moles first. We're going to go from the moles of the iron 3 oxide to moles of the carbon. We can't go straight from moles of one thing to grams of another. We have to connect using that mole to mole ratio from the balanced equation. Okay, so once we know moles of carbon, then it's easy. Then we can figure out grams of carbon because we can use our molar mass. Okay, so this will be step 1 and this will be step 2. So for step 1, I'm going to take my given and then multiply it by a mole to mole ratio of the conversion factor from the balanced equation. So I've got 2.5 moles of the Fe2O3, multiply that by conversion factor from the balanced equation, and then I should end up with moles of carbon. Okay, so moles of the Fe2O3 should be on the bottom so that it can cancel. And then at the top, I'll have moles of C. That should be what's left over, right? So those are diagonal from each other, those moles of the iron 2 or the iron 3 oxide. So they'll cancel out. Now, what should the numbers be here in front of my units in the conversion factor? They will come from the balanced equation. So there's an understood 1 in front of the Fe2O3, and then there's a 3 here in front of the carbon. So when you do that multiplication, you should end up with 7.5 moles of carbon. That's how many moles of carbon are needed to react with the 2.5 moles of the iron 3 oxide. Okay, so now that we know how many moles of the carbon we need, we can figure out how many grams, like how much would 7.5 moles of carbon weigh. Okay, so step 2, I will take my 7.5 moles of carbon and I'm going to multiply that by another conversion factor, and this one will come from my molar mass. And then I will end up with grams of carbon. So if I look at my molar mass, which I have written here, and I just took that from the periodic table, mole should be on the bottom and gram should be on the top because I want those moles to cancel out and I'm going to be left with grams. And there's 1 mole equals 12.01. Okay, so when you do that multiplication, you end up with 90.1 grams of carbon. So that means we need 90.1 grams of carbon to react with 2.5 moles of the iron 3 oxide. Okay, so we've put two skills that we've already learned together to solve one bigger problem. And when we use a mole-to-mole ratio like that, that's called stoichiometry. So well done, miigwech.